Hey guys, welcome back. Yesterday you watched a video on the law of conservation of energy. And basically what the law of conservation of energy is it states energy cannot be created nor destroyed. That means energy can't just appear out of nowhere or disappear, but instead can be transferred. That's how we get one form of energy and another form of energy. It transforms, it transfers. And that's what the law of conservation of energy is stating. Now, you see the law of conservation of energy in many, many different things in life. But one of those things is roller coasters. Also, during this week, we've been talking about potential and kinetic energy. And both of those types of energy or forms of energy are seen in roller coasters. So before we even start the simulation, I want to talk about the simulation. So if you see this picture right here, we have a roller coaster cart and the entire roller coaster. We have the long hill it goes up, we have the one loop, and we have the end of the hill, that last hill. It's kind of a lame roller coaster if you ask me, but it's a roller coaster. Now you can see how fast you're going right here. It tells us how much our velocity is at every given point. It also is going to tell us how much of the potential energy is being used, how much kinetic energy. And we're going to see that through this bubble. So if it's a lot of red, it means there's a lot of potential energy. If it's all red, it means it's all potential. If it's all blue, it's all kinetic. If it's some blue, it's some kinetic. So that's essentially what this is showing us. Now, when do you think, make a prediction, when do you think we're going to have the greatest amount of potential energy? Is it going to be here, here, or here? A, B, or C? When do you think we're going to have the greatest kinetic energy? A, B, C. Okay, you made your predictions. Now let's go through the simulator. So we're going up the hill, we're going up the hill, we're going up the hill. All potential. Then goes kinetic, more potential, then we get all kinetic, and then we stop. It's very fast, and we can't stop it. That's the one thing I don't like about this simulator. So instead, we're going to go through it again. Now this time, I want us to pay attention to the velocity. 2, 3, 2, 3, 2, 3. We go to 20, back to 12, back to 9. So we see. What you're seeing, what you should be taking away, as my roller coaster is going up the hill, it's moving very slowly. We're building potential energy. Our kinetic energy bar isn't that high, but our potential energy bar is really high. Then we get to the top. And when we're at the top of this hill, before we go down, all of this bubble is potential energy. It's all potential. That's because it's at its greatest point. The cart is at its greatest height. It has the most potential energy. So when the cart goes down, that potential energy is going to be converted or transferred to kinetic energy. And that's why you see the car speed up. So it's speeding up because it's getting kinetic energy. That potential energy is becoming kinetic. That's why you see the bar change. And when the bar changes, the speed changes. When this bubble is full of blue, the velocity increases. It goes down the hill. It's kind of still going fast, and then it has to go up the loop again. So again, it's going to lose some speed. It's going to lose kinetic energy. It's going to gain more potential energy, and then it switches again. Then it goes up the hill and does the same thing. So there are patterns here, and I know it's a little fast, so we're going to look at it one more time. Notice, we're building all potential, then it's kinetic, potential, kinetic, kinetic. When was the cart fastest? Was it fastest here? Was it fastest here? Or was it fastest here? A, B, or C? Let's run it one more time. We're going up, we're going up, we're going up. We hit 20. Yeah, right around this area we hit the fastest speed. We hit a fast speed again here, but over here we hit 20. We never went to 20 again after this, which makes sense. Because if you think about it, our potential energy was greatest here. That means our kinetic energy should become really great here. That transfer, that conversion makes kinetic energy. So, that is what the law of conservation of energy looks like. This is a fast simulation. It kind of goes by fast. What you're going to do is you're going to answer the questions that correspond with this simulator. If you have any questions, message me and I'll get back to you. Bye, guys.